Okay, 1, 2, 3, 4, right? Keep going, huh? Keep doing, huh? 1, 2, 3, 4. First step, I'm gonna do 1/5 minus 2. Okay, do that. Step 2, step 3, and step 4. Correct, yeah. There you go, that's the inverse. Any question? Oops, my bad. Yep. Hold on. There. Okay. So for x in terms of y, that means I'm looking at this x. I want it to be alone, isolated, one side. Y plus 2. Okay. I need to get rid of that 1/5. How? Raise both sides by 5. Then I will end up with x equal, I'm going to flip it too. I want to look like this. Y plus 2 to the power 5. Okay. Step 3, that is inverse in terms of y. Okay, that basically your inverse function right there, but in terms of y. Step 4, rewrite the whole thing, rewrite everything, but flip the y and x. Okay. So this and that, they are inverse of each other. In other words, they inverse of each other. That means it's not a one way. If I start a problem with this, if I start a problem, somehow g of x or h, right? I start a problem like that, right? And then I ask you to find inverse. You're gonna do all the 5 steps, right? I mean 4 steps. 1, 2, 3, 4. Eventually, you're gonna end up with the answer, which is that, right? So they are inverse of each other. It's not one way direction. That not mean this one is inverse of this one. When you say that, that means this is inverse of this too. Okay. Next one. That's your homework. Yeah, so if you see this, that means 3.2, the homework also the same like yesterday. The homework will be handwriting or, tablet writing and upload. Okay. Try that. This homework. Try that. It's your homework. Do it now. Later, go home, copy and paste. Try that. X is on the bottom. Okay. Just solve for x. Solve for x. Inverse, inverse, inverse. So for x in terms of y, technically when you solve for x in terms of y, you're done, right? You just change x and y, you get your inverse. Okay. I give you the only first step. The first step is this. Okay, second step. How do you solve for x? What would be the first idea to solve for x? To pull out that x. It's on the bottom. How do you pull it up? Pull it to one side. What will be your first thing to do? Last two example, you take a cube root, you raise to power 5. What do you do with this problem? How do you rotate an equation? How do you rotate a fraction? There's multiple way, but the best way, okay, force it. Brute force. I want this on the top, then make it on the top. You have to follow your command. It's on the top. Then what happened to that y? That y is on the top, right? Can I write it out? Y is y divided by 1. Remember, I abuse number 1 a lot, right? Number 1. There you go. Then you solve for x, blah, 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 until you get that. But step 4. I'll let you work on that. Okay. Graph of the inverse function. We want to learn the inverse function. What do they look like? What do they look like? Okay. I will recon this one. Graph. Right? We found out the inverse is that. What does it look like? What does it look like? Another way of writing this. Okay. I want to write in exponent. This is root form. Exponent form will be, what will be the power?
Actually,
1/3.
1/3.
Okay, 1/3, maybe half of it. Okay. 1/3. Remember that? Square root, 1/2. You only have the upper half, you don't have the bottom, right? 1/3. Right? Okay. So that is one example. I want you to look at these two, just the plot. What will be your conclusion? What will be your reasoning? What can you tell about the relation between the graph of original function and its inverse? Think. Think. Give me some comment. There you can. Start with you.
It's a reflection over y equals x.
Beautiful. Beautiful. It's a reflection. First of all, we can see that it's a reflection. Some form of reflection, right? And then you have to ask yourself, reflect over what? Is it reflect over x-axis or y-axis or something? If it reflect over x-axis, no, it's not. If it reflect over the red one, reflect over x-axis, it looks like this, right? Which is not. Reflect over the y-axis. So the red one is going to be over here, right? Which is also not in this case. How do I reflect so that it be like this, the green one? The only option is to reflect over this line right here. And that line happened to be the line y equal x. Okay. And that also the rules for the graph between original function and its inverse. they reflect over y equal x. Inverse function. Okay, so y equal x, it's just a diagonal line equal x. So let's say if I draw something like this. Okay, you can draw anything. Try it. You can draw anything on the top. Okay, now let's try to draw the inverse. Okay, try that. So could be anything. Okay. So this would be f. What would be the inverse look like? Draw it. Okay, reflect right. So maybe over here, like that. I try my best. Yeah, a little bit longer, but it's okay. Yeah. Maybe that. Okay. So reflect over y equal x. Okay, not over x axis, not over y axis. Using that idea, this is the idea. Let's sketch some actual function. Okay. First, I want you to sketch the original of this one. I want to give you the idea. Okay, the model function of that would be square root of x, right? The model function of that would be square root of x. I give you the square root of x. I hope you still remember the function transformation, huh? That's just number one over there. Okay, so square root of x. Model function will be like this, original one. But now, not graphing the inverse, just that function. But now, okay, that is square root of x. Graph this using function transformation. Recon function transformation. Plot that. Up, down, left, right, reflect, blah, 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 blah. Okay. You need that. You need that for this section. Okay. If you don't, make sure you go back to the note from 112b, 113, recon function transformation. Okay. You're going to shift the function around a lot, and then you're going to plot and after that, you will be plotting the inverse. Nah. Way off. Plot that. Shift, but not down. No problem. Okay. Can I rewrite like this? Right? So originally I have this. That been like this. Don't draw it yet, don't draw it. That is that. Then what happened if I put a negative there. Let's do one by one. It's going to reflect, right, over y-axis. If I put the negative outside, then reflect over x-axis. Put the negative in front of the x, it becomes like this. Okay? Now I plus 1. Now I'm shift up, down, left, right, plus 1. And also there are two kind of shipping, huh? Inside and outside. We have the first one, not the other one. That is two different directions. The first one will be
A shift to the left by 1 unit.
plus 1. Shift to the left by 1 unit. Hold on. You remember? It should be shift to the right, right? Plus 1. Hold on. Let me do the calculation. X plus 1. Oh yeah. You are right. 1 unit. There. How about the other one? Okay, so this is left. This is up. Okay. So maybe you're gonna see that. Actually it's down here. Okay. All right, so now I know that will be the plot of the original function f of x. So you have that. Next thing you want to do, draw the reflection line. Yeah, actually y equal x. In this problem, it's called reflection line. Now you're able to draw the inverse of that one. The reflection of that one. Okay, so what do you draw? Think about that. Reflection of that one. -1 here. For sure I will stack at -1 down there. Okay. Okay, which one? Purple, black, red, blue. Red. Okay. Try again. X cubed plus 2. Try again. X cubed plus 2. Remember, in the quiz or in the exam, you don't have graphing calculator. Maybe you have graphing calculator. If you're able to graph using graphing calculator, then good. But most of the function I will give to you, even graphing calculator cannot graph it. You don't have enough space to graph in the graphing calculator. You need to recall function transformation from your pre-calc. Make sure to revise reflecting, stretching, compressing, constructing, shift up, shift left, shift right, shift down, down. So this one basically x cubed up by 2 units, right? X cubed up by 2 units. X cubed up by 2 units. So xq normally like this. 1, 2. Okay, literally move it up to unit. Right. Okay. Reflect that over the y equal x. And I think of that. Okay. Try that one. Okay, let's move on. I don't want to spend more time with this. That will be your homework. Again, I'm going to highlight here. I'm going to highlight for you. Okay. That's similar to this. The xq, shift down, plus 2, right, shift left. Okay. Inverse function. Why do we find inverse function? We find inverse function and then we want to find the derivative of that inverse. The derivative of that inverse. And this is one of the, okay, I would be honest to you, this is one of the most tedious formula in this class, in Calc 1. Derivative or inverse of a function. I'm going to skip on the proof why I come to this. Okay, this is the kind of thing that you're going to use. Okay, so we're just going to yield a result. We're not going to try to prove it. It's long, it's tedious. Even the formula and the result already look ugly. Okay, but we just apply this. Just going to follow the pattern right here. 1. Okay, that is simple. 1 divided by, but that thing down there, that denominator. We have a lot of things to talk about that denominator. Okay. So in here you have derivative of the inverse at a point. Okay, so we're going to do that. Okay. Okay. This one is, there's a typo, not really typo, I'm missing something. When you do this problem, I'm going to ask you derivative at exactly 1 point. So derivative, inverse derivative okay, this means derivative of the inverse at 1. Simple. Derivative of the inverse at 1. Okay. Because finding this is difficult. So that's why I shrink the problem down to just at 1 point. So you can have you have some number to plug in. Okay. Relatively easier than finding the x general. This is general case. This is specific case when x equal 1. Okay, but we still use this one. So right now, we try to find this at 1. So let's write this. Okay. So f inverse, then take derivative at 1. And according to that formula, I have this fraction where x equal 1. So rewrite this one again with 1 right there. Okay. So to find the answer to this, you find the answer to this. In here, now let's try to use this, your understanding of just math, not calculus. How many things you need to identify in here? How many items you need to identify in this denominator? What do you think? Huh? Which is? Actually, 2. Okay, it's like peeling onion. On the way outside, that it is. You need to find the derivative first. the derivative. Two things to find. First is the derivative of x. Okay. Remember this whole thing, this yellow is the x in this case. That. So find derivative of that. That's the first thing. Second thing is that yellow thing inside. So that yellow thing is the second thing you're going to find. That it is the inverse at 1. Okay. Find this inverse at 1. Find the inverse at 1, which is that yellow. What do you think the outcome of this one? This one right here, this purple, the outcome. Is it a variable, something with x, or is it a number? What do you think? The outcome of this one. If you calculate this, okay, you do the math at the end, equal a number or equal something with x. What do you think? A number, right? You're going to have, because of 1 right there, you plug in 1. You're going to have a number, and then that number you're going to plug in right there at that x. Okay, can you find this? Derivative of f prime of x. You have f of that. F prime equal 2 cosine of, sine of x, right? There, you have one number already. Then find this one, the purple one, whatever that is, you're going to plug in right there. Okay. Then, how do we find the inverse at 1? To find the inverse at 1, we have to go on the process. You have to find inverse at x first. We need inverse at x. In other words, we need to follow 4 steps. Step 1, step 2, step 3, step 4. Okay. Step 1, write out y equal f of x. Step 2, I'm going to solve for x. I think I should apologize. I give you an extra x in there. Make this problem too hard for you. Erase that x, because now it's easier. Erase that x. So erase this x. By erasing that x, this means you're erasing this x, you're going to solve for x easier. Okay. So y minus 2 equal cosine of x. X equal, this is where you want to find out the inverse function of cosine. X equal inverse cosine, or cosine of y minus 2. Okay. This is another way of writing this. They're basically the same. Cosine. We're gonna, for now, let's write that one first. We have another section to explain this. We're gonna have another section to explain this. Okay, so x is inverse cosine of this. It's like you taking, okay, if you have x cubed, you take cube root. If you have cosine, you do the inverse cosine. If you have sine, you have inverse sine. Okay. Step 3, the inverse of y equal cosine, inverse cosine of y minus 2. Step 4, inverse of x minus 2. Okay. So that is the inverse right here. We want to find inverse at 1. We plug in 1 right there. So I'm going to add step 5, which is this. Inverse at 1. Plug 1 in. Cosine of -1, 1 minus 2, -1. Okay, you don't need to calculate that number. It's just an expression. Okay. Okay. And one more thing. When you take derivative, right here, this step, because I erased number 2, I erased the x, I only have 2. Derivative of 2, it should be constant. It should be 0. It should be 0. Okay. So in other words, you don't need that number 2. Okay. All right. Now complete the problems. Plug everything in. 1 over negative psi, which is the blue one, instead of this x, which is this x, I'm going to replace with this thing. Inverse at 1. Inverse at 1. Inverse at 1 is this. That purple going to go right here, which is right there. There you go. That is the answer. You don't need to simplify.
So for this one, like the inverse cosine of -1 is pi, and then the sine of pi is 0, so it's 1 over 0.
Negative sine, negative cosine of 1, of -1. Cosine of -1. Hold on. It's negative pi, correct. Sine of pi is 0. Is 0. Which make this D and E? Okay. Yeah, which make this D and E. But for now, let's find the expression. The idea of this expression. If you find the expression, yeah, D and E, we're going to come to that. But why is that? Somewhere in there I put the... I think I gave you a very bad example, right? Originally, that x still there, but solving for the x over here will be too much for you. That's why I removed that x. And by removing that x, I'm removing this number 2 over here, and removing this number 2 over here. That will give this problem actual answer 1 over 2. That's from the textbook. But I don't want to solve you, take you on the way to solve for x over here. That's why I remove. Okay, if you want, okay, that is the expression of the answer. Is the D and E because this turned out to be pi. I didn't come to that. It's another few more sections down the road. Because sine of pi is 0, so you're going to have 1 over 0, negative 0, technically D and E. Okay. At home, if you want to test yourself, do more, the actual problems is this. And it's from a textbook. Okay. Somewhere you have to solve for the inverse, which is y equal 2x plus cosine of x. And remember that is step 1. Step 2, you need to solve for that x. That is way tricky. And I don't want you to go, I didn't want to go down that road because there is x over here. You have x out here, you have x inside the cosine. It's difficult to solve. You can see that, right? That's why I removed that x. And I did that without thinking. By removing that x, I changed this problem. I changed the derivative. I don't have this number anymore over here, right? If I have that x, the derivative is 2, right? 2 minus 0 is 1/2. Then you have a defined answer. But by removing that x, I have 2 minus, I don't have anything, 2 minus 2, 0. Okay. So now I understand why the textbook have 2x. Okay. The textbook has 2x, but I don't want you to do that problems. Okay. It's too much for you guys. In normal semester, in previous semester, we did that. This problem take longer. Okay. So, any other question? Okay, your homework is that one down there. Find G derivative of the inverse at 1 for that problem. Okay. Find the derivative at 1. Same like this problem. Exactly the same like this problem, but for different function. Okay. Moving on. Logarithm function. This is exactly why we learned the inverse for. See in the beginning. Okay. From last section, I told you that the logarithm is inverse of exponential. We spent the last 4 sections, subsection 1, 2, 3, 4, just to explain, just to get the introduction to the inverse function. And now, inverse function give birth to this kind of function. Okay. The inverse function of exponential function is logarithm, but instead of keep calling them inverse, it has a special name. That is the logarithm. Okay. Regular function x cubed inverse that normal. Okay, nothing special about that. We just found what there was just fine. First, D and E. That is not 1-to-1. Another one, sine or maybe cosine, you just over here. Inverse is this. Another way of writing cosine. Okay. They are more or less like individual function. They don't have special property to them. But the exponential function, the inverse of that, logarithmic. This is called, it has a special name. This is logarithm. And this is exponential. Okay. So logarithm is the inverse of exponential. It has special name too. Yeah, the name is logarithm. Instead of calling inverse of exponential, instead of calling inverse of this, the special name for exponential, logarithm. Okay, any question? Recall exponential f of x equal a to power x. Some condition, a is greater than 0, a is not 1, because if you have 1, you have exactly return 1, okay? A is greater than 0 because you don't have negative base. Then the inverse function of exponential function, we write like this: f of x equal a to power x if and only if, let me make sure you have the correct notation, f of x equal a to x equal, okay, actually rewrite this, y equal a to power x equal logarithm base a of y. Okay, and from here to here, we're supposed to do 4 steps. Remember, find the inverse function. We're supposed to do 4 steps to find the inverse function. Logarithm function is special. We're going to go to the result right away. Skip a step. Skip on those 4 steps. You're supposed to do this 1, 2, 3, 4. Then you end up to this. Okay, we skip all of that. Come out to the result right away. Okay. Okay, inverse function of exponential function is a special case with its own name. There you go. Now you have a formal definition, formal names. Logarithm function. Okay. Any question? Okay. I give you the idea why we study logarithm. Why we study logarithm. To know the idea why we study logarithm, can you give me the idea why we study exponential? Why we study exponential? What is the application of exponential? Yesterday I talked about this. What is the actual application of exponential in real life?
Like continuous growth.
Continuous growth, exponentially growth. Okay, anything that has growing. Okay. The best context is anything with time. You put, instead of calling x, you put time in there. So literally you can tell them in the beginning. 1 month, 1 year, 2 years, a decade later. Okay, right? That is actually the application of exponential in real life. Then logarithm is the inverse of this. Okay, think of it if this is time. Logarithm, okay, I'm going to give you the plot right away. Logarithm tell you this. That is the plot of logarithm. Down here, inverse of that. Actually, no, my bad. It's intersect one. That is logarithm. Okay. This literally like a time machine. You rotate the clock backward. Usually you've been asking, okay, you most of the time you've been asked the question, I start with this much money. 10 years later, I invest in a bank, invest in NVIDIA, invest in Google. 10 years later, a decade later, how much do I have? Okay. Then I also have another question. Right now, NVIDIA or Google, Meta, stock is like this. I want to go back a decade ago. What did they perform? How did they? What is the stock price? Okay. Look at the patient blood count, blood cell counts right now. I don't know what's the unit of blood cell count. Okay, let's say 2 million something. I want to rotate. Okay, the question ask nurse or ask the doctor. Okay, last month, how much was it? So I can prescribe. Okay, last month, 24 hours ago, 2 hours ago. I'm about to go into surgery. I need to know the blood count pressure, blood cell count of that patient 24 hours ago, 48 hours ago. You rotate the clock back on of that calculation to answer all the question. What happened a couple of times ago, months ago, years ago, hours ago? The answer by using this. The question for the future. Right now I'm growing bacteria for experiment. Right now the first hour in the starting I have around 500 in my population. Okay. In 48 hours, how much should I expect? I use this question, I use this model. Okay. Understand? So that is the reason why we learn this. Nothing in vain. Okay. The best way to rotate the clock back is more or less these two. Literally in finance, in physics, they call that is the time equation. Both of them, time equation. One tell you the future, one tell you the past. They are time equation. Very fancy name, but a lot of application. Okay. All right. The notation I just gave it to you. Okay. Inverse function. This, how do you read it? One side is exponential. I think you can read it, right? This is read out like this. Logarithm base A of x. Logarithm, that's how you read. Logarithm base A of x. Okay. Is the reverse, inverse of this. Okay. And what is this? The property? Okay. They look nothing alike because we haven't gone through those 4 steps to show you that how to find this. If we go actually in the textbook, if you want to read more, y here. So for x, blah 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 blah, and then step 1, step 2, step 3, step 4. How do you end up to something? Where this letter come from? Right? In the textbook, explain clearly. But they are inverse of each other. The only thing they say a lot of things. But the thing they say also the same names. Is that base? Exponential had the base. Whatever the base in exponential function remain to be the same base in a logarithm. Okay, so the base in both case remain to be the same. There also base A in exponential. Okay. Some example. 2 to the power x. Okay. 2 to the power x equal y if and only if y equal, how should I rewrite that? I mean, no, not y equal, x equal right. Use another variable, a half, no, not a half, maybe a third of u equal v. U equal 1/3 of v. Okay. Maybe q, negative q equal p. What would be the inverse? Okay, so we are just, right now we just rewrite exponential in terms of logarithm. Okay. negative negative q equal logarithm base 4 of p. Okay. How about logarithm base 3 of w equal t? How do you rewrite this? Okay, now we've been going from left to right, having the exponential rewrite in logarithm. Now we have logarithm. Exponential form would be, okay, there's an equal sign. What would be on the left side? What would be on the right side? What do you think? W is left or right? Okay, either way, okay. If I put W on the left, okay, right side? Huh? There. Okay. Any question? You want to use actual number. Two to the power 4. 2 to the power 4. 16. In logarithm, this is actually mathematically correct too. Using those three numbers. In logarithm, you have logarithm base 2 of 16 equal 4. That is actually correct. If you also practice using logarithm in your calculator, huh? Press this in calculator, you're gonna have 4. Okay. I want to use this to you. Two to the power 4 is 16. Okay. Okay, got it. Let's say I'm trying to make an example. I start growing my farm, okay, with, let's say, I'm trying to guess an animal that also makes sense. Give me some animal.
Cat. Chicken.
Chicken. Cat. An animal that kind of like fast to multiply. Chicken. Yeah, chicken, right? Chicken rabbit. Okay, I start with 2 chicken. Every month it's multiply, right? Double the number. I start with 2 chicken. Then usually I ask you a question. 4 months later, how many chicken do I have? How do you do that? Every month you double the chicken. I get double the chicken. 4 months later, right? 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 Raise to the 4. 40 months later, raise to the 40. Right, and then so on. Okay, that's too much. I don't think your calculator can have output for that. That's actually extremely huge. 2 to the 40 Your calculator running out of space. Running out of space in the line. Okay. That's huge. Okay. Then, same thing. Right now I have 16 chicken. Okay. I raise also same question. Your friend come to your 4 months later. Your friend come to your farm, your hut, cow. Oh, you have 16 chickens. How long you been growing them? And you know that in the beginning you have 2, right? You don't know 4 months past. You don't know that. Couple months later, your friend come by, see 16 chickens, cow 16 chicken. Okay, I gave you 2. Okay, actually, that 16 chicken came from the 2 chicken that the friend gave it to you. Okay, couple months ago, I gave you 2 chicken. How can you raise them so fast? It's 16 now. How long did you grow them? Four months. Okay, not everything you learn is just a bunch of number. Okay, and don't think of chicken. Now move up. Think of money. Think of medicine. Think of investment. Think of construction. Time to build something. Time to invest something. Time to heal something. You break a bone. Okay, you anything in there. Okay, that is logarithm. Back and forth. Okay, some law with logarithm. I want to show this. What can you do the math with logarithm? First one. Logarithm by a of a equal 1. Base a of 1 equals 0. Okay. Logarithm base a of a to power n. This actually power rule. Okay. This actually power rule. Power rule in logarithm that n can go on the way to the front, drop it down. Okay. Actually x. A of a. Okay. I want you to change a different thing. Because a of a will be 1. Okay. You can do a couple of operation with logarithm, such as adding. So x and y. If you want to add two logarithm, first thing they have to be the same base. Okay, they have to be the same base. Then you combine them into one logarithm. 2 of them, combine them into one logarithm. Again, return the same base. But that x and y will be x times y. Okay. By that analogy, if you have minus, subtract between the 2 logarithms, with the same base, it returns a product. I mean a quotient. A quotient. Okay. So they basically are more or less like a product rule. There's a quotient rule for logarithm. Product rule, quotient rule for logarithm. Okay. And these one, remember, these are equal. So if you have one, you want to split a logarithm into 2, this is how you do. Okay. There's one thing you be mindful, is that if you have logarithm, same base of x, times another logarithm, same base of y, okay, you have this. You have nothing. There's no formula for that. Okay, I want you to write that down. Also for the same division. Okay. Okay. Addition of two logarithms, subtraction of two logarithms, clearly two logarithms return one logarithm. In other words, you are combining them. You combine them. You combine into two one. Okay. But a product between two logarithms, okay, this is a product of two numbers inside. This is a product of two logarithms. There is no formula for that. You cannot do anything. Okay, it doesn't return anything. Okay. Same for division. All right, so let's take 10 minutes break. Come back, we're going to finish this section. Okay, we do some math for that.
Mexico winning that shit. Nah, bro. I feel like we're trying, bro. I don't know why.
Nah,
I have the feeling.
2-0.
I feel like it's gonna.
I can't say too much today.
Why?
I got asked to go piss off.
You can put lines during the day.
Yeah. After practice.
But they tell you after or what? Yeah, I was excited too.
I'm gonna get it.
Okay. Let's keep going with the yes. Okay, some laws. What can we do with logarithm? Okay, apply this one to here. So simplify this means you either you expand, if you have one term, you try to expand into as many terms as possible. Or if you have multiple terms, okay, for this example, you want to combine to exactly one logarithm, okay? So one by one. This one going to be expanding. Expand this one using the property of both. Okay. So let's say I have 1, 2, 3, 4, 5. Kind of like 5 formulas. Which one do I go to do this problem? 5. The last one, right? All right, one. One. So I see a division right here. I see a division. Okay. I'm going to break it into 2. Okay. Become as a subtraction. That's subtraction. 2 logarithms with the same base. Which base are we talking about? 3. So base 3. Base 3. Okay. For the first one, base 3, okay, only base 3 of something. Base of something. Okay. Base of something. Base 3 of the numerator. Base 3 of the denominator. Okay, so I'm gonna write smaller. Okay. What else can I do with this? The value of them, evaluate. And however, look at this one. We can calculate this. We can do something with it. But this 9 times x. 9 times x. 9 times x. Right? We're going to use that formula. So maybe smaller. Okay. So 9 times x. It will become a product, become an addition. One more time, same base. 3. Okay. Minus 3. Leave it there. Okay. That 27, I'm going to talk about that. I'm not going to write 27. I'm going to write something else. But for these two, right here. 9x, 9 here, x here. Agree? Okay. So 9x. 9 here, x here. There. But that's 27. Okay, 27. I'm going to use maybe purple. I want to simplify that. 3 and 7. I can see the connection. 7 is... How's this relation between 7 and 3? Go ahead.
You can say 3 raised to a number equals 27, and then the number in this case is 3, so the answer is just 3.
3 raised to the number, which number would that be?
3.
3. There, right? 3 cubed. 3 cubed equal 27. Okay. Okay. So keep going. I have, okay, plus 3 of x minus 3. Okay, I'm going to be as low as possible. What did I do? What did I do here? I do the power rule. A power rule for logarithm. That power inside, I can move it to the front. Drop it right here. There. Okay. And that's 3 and 3. That one, okay, is 1. This equal 1. Because that, the base and the number are the same. Okay, base A of A, base 3 of 3, base 4 of 4, base 5 of 5, base 10 of 10 equal 1. Okay. But how about this? I leave something blank here. Same idea. 3 square. 3 square. There. And again, one more time. That would be 2. Okay, right? 2 go to the front. 3 of 3 equal 1. All right. Combine those two numbers. There. Okay. So that are the math, that are the operation we can do with logarithm. Okay, can you try that one? Okay, and just so you know, whenever you don't see the base, there is a base in there. It's not invisible. There's a base in there. And that base is also very common. Second to natural base, natural number. There are 2 very common base. The first one is base E, which we write like this. In short, natural number, right? Logarithm of natural number, that is natural log. Talk about this. The second one I haven't talked about is base 10. Base 10, because also very common, they usually omit that number. It's like square root. Couple hundred years ago, there's nothing look like this. It's supposed to be this. Okay, and because square root used so often, you can understand that is square root. As long as you put different number, now that's cube root. But you notice that is square root. But there's number 2 over there. Because it's so common, people don't write that number 2 anymore. Logarithm base 10. That is base 10 there. And even shorter, in some textbook, you're going to see that just write LG. Okay. It has also had another name too. It's called common log. That's been base 10. Natural log, base E, common log, base 10. So whenever you see no base in there, don't assume it's a typo. There's a number 10 there. Okay, there's a number 10 there. Okay, then do this. Expand it out as far as possible. Expand that. Write as many terms as possible. That problem, everything is about base 10. And you don't have to write about number 10. I also understand that. If you don't write a number, I assume that it's going to be 10. Okay, what do we do first? Okay, here is something I see a lot. First, will be a mistake. You don't do this. Okay, you don't do that. Equivalently, you don't do that. Okay, you don't do that. In fact, this one, the 2 go to the front, right? 2 logarithm base x. Okay. That square root. That 2, in fact, it equals 2 logarithm base there. So if you cannot do this, then what else can you do? You can split them up, but you can split if and only if it is exactly x or y, nothing else. You're about to use this formula, right? You're thinking about this. But look at that. Purely alone, x and y, nothing else. Not 2x, not 2y, not x squared, not purely alone. We've been playing with this technique many times. 1/2, right? And that 1/2 is nothing more than a power. Go to the front, drop it down. Now you can split plus okay. Okay, 1/2. Next. Now combine. So these problems are more or less like expand. You expand, now you combine. They are the same base, so I think you can do that, right? So 2 by 2. Let's do 2 at a time. I see subtraction. I want to combine into 2 into 1. I have to maintain the same base. First of all, for sure. Okay, keep that same base too. What do I do with this 16 and 2? I will divide. Okay, drop the last one. 16 divided by 2 is 8. All right. What do I do? 16? 8 plus 8? No, 8 times 8. 64. Multiply, correct. Okay. I also know something about 64. It's 2 raised to the power of 2 4 is 16, 2 5 32, 2 to the power 6. All right. That equals 6. Okay, that's one way to do this problem. That's one technique to do this problem. Combine them. However, another direction, I'm going to use another color. Each one of these I also can simplify right away. 16. 2 to the power 4. The middle one. 8. 3. That equal 4, right? That is 1. That is also 1. 4 minus 1 plus 3. 6. See? Logarithm is just another kind of math. Okay. It's simple. Last section. Any question? Natural log. Base is the most common logarithm, written as logarithm base e. Okay, but instead of logarithm base e, and also have the name natural. The letter n come from natural. Natural log, ln. Okay, so ln, natural log. We're gonna solve. Okay, let's practice a problem. Solve for x. So for x, maybe I bring this one. Okay, e to the power of 4 minus 3x equal 4. Okay, I'm gonna solve for x using natural log. This is exponential function. Clearly, x in there. I want to solve for that x. I want to solve for that x. In other words, I want to bring that x down. Okay. There's a technique. If your variable, if the x, the y, the unknowns is in the exponent, the first thing you want to do is you want to bring it down to the round level. This round level, exponential, round level. The base down here, right? Okay. So round exponential. How do I bring it down? How do I bring it down? There is a special property in logarithm that can help me bring it down. Bring down an exponent. Right? It's very powerful. It's reverse of the inverse of exponential for a reason. Inverse everything exponential do. Okay, but this apply if and only if you have this thing. You have that. It's like this logarithm con this property. No other operation, no other function have that property. My problem right here, it's just exponential. I don't see any letter. I don't see this. I must pop that up to use that property. Then what can I do? I'm going to apply logarithm both sides. This is called apply logarithm both sides. Let's think of like you square both sides. You subtract both sides. Okay, you've been doing that for years now, right? You subtract both sides, you divide both sides, you multiply both sides, you square both sides, you take square root. You do everything both sides, right? Today you learn a new thing. You apply logarithm base e both sides. Okay? You apply logarithm. It's not multiply, remember. This is an operator. It's not a multiply by this. You apply logarithm base e. The correct word is apply logarithm base e both sides. Okay, apply, not multiply. Not multiply. Okay, that's a different operation. Okay, so there. Now left hand side is done, right? The exponent. You're able to throw that to the front. And look at logarithm. Okay, if you throw that to the front, logarithm base e of e 1. But on the right hand side, okay, usually I apply logarithm base e, but instead of saying logarithm base e, ln. Okay, so literally in the beginning you can write like this. Okay, eventually you're gonna write like that. If you get used to the notation, ln. Okay, so time 1, nothing there. Now the x down there, you can solve for x, right? 4 minus 3x equal ln of 4, natural log of 4. Okay, you can solve for x. Okay, another common mistake. Another common mistake I see a lot in my 112B student when I teach them this. Question. Is it?
No.
Logarithm base, okay, ln of 4 and then minus 4. Is it? No. No. Okay, you only subtract when you have the same base. Yeah. Okay, so how do I get that? Okay, let's say if I want that to happen, not equal that, then Okay, this is extra. If I want this, I need this, I want this to happen, what do I do with this? Just a minor details. What do I add to give me 0? Parentheses. Okay, so now 4 minus 4 is inside that natural log. Right here, only this 4 belongs to this natural log. That's negative 4 outside. Think of is that psi of 0? No, right? Psi of pi minus pi is not 0, right? Nope, not 0. That is 0 minus pi. That is negative pi. Now that is psi of 0. Right? So you know which one belongs to which, right? Know their location, okay? All right. Done. There. Any question? Okay, tomorrow we're gonna learn more about logarithm function, derivative of logarithm function. Okay, tomorrow we're gonna learn derivative of this logarithm. We learned derivative of exponential already. Tomorrow is derivative of logarithm. Okay, quiz time. Quiz time.